Hi everyone, welcome back to another video. So we've now finished nodal analysis. That's done. So now we're going to move on to mesh analysis. So similar to nodal analysis, mesh analysis is basically another technique that you use to find currents. But this time it's not nodes, it's obviously meshes. So let's go through what a mesh is. So a good way to think about a mesh is that if you have if you have a circuit, a mesh would be a closed loop. So if you started from here and you went around this circuit this way, went this way, and this way, you'd end up back where you started. That would be a closed loop. So that would count, this whole thing would be one mesh or one loop. Another way to look at another type of circuit that you could have is you could have an open circuit. So for example, you might imagine you had a bunch of circuits and components in here, and then you had some connectors whereby you came and then you stuck a device, you connected it onto there. So this bit here is an open circuit, so this wouldn't count as a mesh because you couldn't go from here up here, down here, and then back down to here. It's open, so that doesn't count as a mesh, right? That's one way to think about meshes. So the official definition of a mesh is that it's a path through a circuit that starts and ends at the same place, right? So a path through a circuit, you start here, go around, and you end up back at the same place. That's one mesh or one loop. Typically, the way that you would see a circuit look when it comes to meshes is you might have, for example, a big circuit. We'll do voltage source here, plus minus. We'll do resistor here, resistor here. Have another one along here, put a capacitor there, and you can go with another resistor there. Okay, so if you had this circuit here, then you would have one mesh, two meshes, and three meshes. Cool. Okay, so let's go over the steps when it comes to solving for mesh analysis. And again, as I mention every video, I'm not teaching this, I'm just revising myself, and then obviously just allowing you to watch along with my revision. So if this is the first time you're going through this, it's probably not going to be too beneficial. So yeah, just bear in mind, I'm a student, not a teacher, right? All right, so when it comes to the steps for solving mesh analysis, same as nodal analysis, there's basically 6 steps, right, that you're going to have to go through. So number 1, you're going to label everything again. So what I mean by label everything is that you're going to basically draw all of the currents, right? And you're going to draw all of the directions and the meshes, right? Again, when we do the example, that this will make sense to you. Then we're going to do the KVL for each mesh. However many meshes there are, we'll do the KVL for them. Then after that, we're going to do the formulas for each branch, or the currents for each branch. So the formulas for all branch currents, right? And then so the key point here, which maybe I should write down, let me just do it in a different color, is that it's the formulas for all branch currents in terms of the meshes. In terms of meshes. And what I mean by that is that I don't know if I should go into it now, but I'll just write it here and then we'll explain it when we go through the example. But you'd have, for example, I1 is equal to I1, which I know if this is your first time looking at this, you're going to be like, what the hell am I talking about? But yeah, it'll make sense. And you'd have like I1 minus I2, for example. Oops. These kind of things. Again, we'll do the example in a minute and it all kind of makes sense. So once you've done the formulas for the current or the branch currents, then you're going to do the substitution into the KVLs. So substitute into KVLs. Then after that, you're going to do the lovely simultaneous equations. So if you're a first year and you haven't brushed up on simultaneous equations, you have to. Like, that's what all you're going to be doing your entire first year, simultaneous equations. Then last thing to do is to basically substitute again, same as what we did with nodal. Substitute into current branches, right? And what I mean by that is that you basically say, for example, I1 is equal to I1, which is equal to, I don't know, 1 amp. Yeah, you'll get it in a minute. Okay. All right. So let's do. Okay, before we do an example, I'm going to make an important point here actually. When it comes to doing the mesh direction, the mesh current direction. Mesh current direction. Now this confused me a lot, and even on my final exam I made a mistake on this and this cost me marks. So yeah, try and keep this in mind. So usually when you have meshes, you always kind of get like this. Usually this would be a resistor here, and you'd have basically, if you can see here, and if you haven't done this before, it's not going to make sense, but you've got this current going this way, so it's going down, right, positive to negative across there. Then you've got this current going this way, so this one's actually going up, so that's going to be positive there, negative there. Then how do you define this mesh current here? It gets confusing. So yeah, we're going to do it in an example anyways, but just let me just give you an important point to remember. So let's say you've got minus, plus there, you've got I2 going, you got I2 going down that way, and then let's call this resistor R3. So what we're saying is, what is the mesh current for I3, right? So I3 here would be equal to minus I2. This is a bit crazy, but it's an important point. So the mesh current I2 is coming at this component R3 from its minus side, from minus, right? So that means that you're going to be minusing, the current is going from minus to plus, so it's going the opposite way. Remember, because the current will be going, current flows, you know, positive to negative. So this is coming negative to positive. So you're actually going to end up with a minus when you're doing the mesh current directions here. Again, you know, more than likely when I actually do the example, I'll probably make this mistake as well. And thankfully I've learned to just, I don't trust myself and I double check. I've started to, now I catch it, but I made this mistake in my exam anyway. So just an important point on mesh current directions, which if you didn't understand any of that, don't worry about. Let's just do a whole example now, and hopefully it will just make sense. Cool. Okay, so let's draw a circuit. We'll start off with a battery, do a resistor here, do another. Let's just do the standard one. This is the standard one I'd do. Let's go with a second voltage source. We make it really complicated. I don't know why I do this to myself. I'm going to regret this. In about 10 minutes time, I'm going to be like, why? Let's do 3 voltage sources. Right? We could flip one of them around, but let's just not do that. Okay, so you got positive, negative, positive, negative, positive. Okay? And so we've got 3 resistors. Let's go R1, R2, R3. Okay? And then we're going to go, let's give them some values. I don't know, go 6 volts. 4 volts, make it 10 volts, and then 10 volts there. So you got 20 volts in total, and then let's go 20 ohm resistor, and then we'll go another 20 ohm resistor, and then lastly add it together. Let's go 40 ohm resistor. Okay, cool. So you can see how now, if you was to start trying to analyze this with just Ohm's law, I don't even know how you do that. That'd be a headache. But when it comes to doing meshes, this is actually quite simple. So if we take this circuit, I just want to duplicate this circuit. In the last video, I ended up drawing all over the circuit. It became a pain to rub it all out. So just save that there. Okay. So let me copy the steps as well, actually. Nice to have them with us. Okay, so step 1 is to label everything. So the first thing that we can label is the mesh current. So we've got 2 meshes here, right? We've got this mesh and this mesh. That's 2 loops, right? So we can say this one goes this way, I1, and this one goes this way, I2. You can do it any way you like. I've just learned to get in the habit of just doing them both going the same way, so that when they go through this resistor here, they're going through opposite ways. It just makes it easier for me personally. That's just what I've done. So yeah, you can do it any way you want. Same as Nodal, it works its way out anyways in the end when you end up with minuses and pluses, so it's fine. Okay, so we just now need to draw the current through each resistor. So we can do it this way, we can do it that way, you can go that way, it doesn't make a difference. Again, don't get too caught up on drawing directions, just draw it however you want. So I'm going to say that this resistor is going this way, I'm going to make this one go this way, and then I'm going to say that the current's going down this way. Cool. Okay, so now we've drawn our current directions for each branch. So, you know, obviously this one would then be going that way, this one would be going that way, this way, blah, blah, blah. So everything's fully labeled. So that means that we've done step 1 now, right? Okay, so step 2, let's do the KVL for each mesh. I've missed something out here because we need to write the currents for each resistor, same as what we did with Nodal. So let's do the KVL then. So for mesh 1, if you don't remember KVL and KCL, 2 videos ago I did, or 3 videos I did it on the basic circuit laws. So we're just doing, if you remember, the sum of all voltages around a closed loop equals 0, right? What we're saying is that the KVL for this mesh current I1 is going to be, we can call this V1, you can call this one V2, and this one, cool. So now we've got this mesh coming, and this is all over the place, but you've got this loop coming around here, right? So that means that the current's going up this way, correct? And it's meeting this V1 at minus and then going to plus, right? So there's a voltage rise from here to here. We have a voltage rise. That means we have plus V1. Hopefully that makes sense. Please, if it doesn't make sense, you need to get concrete at this. It's very, very important. So that's a voltage rise of V1. And now we've got this resistor. We've said the current's going this way. So this is positive, this is negative. This will be positive, that's negative. This is positive, that's negative. So we've got the mesh now coming this way, and it's meeting R1 at its positive end. So that means you have a voltage drop. So the voltage drop of R1, right? Or you could say I1, really, of I1. Now the loop comes to the resistor R3, right? So it meets it at its positive terminal here, right? So then you have again a voltage drop of I3, and then it meets this voltage source V2 at its positive terminal again. So then it has now a voltage drop of V2. And that could be very confusing because you're like, well, you're coming out of battery, how are you dropping voltage? But think about it here, right? If you've got plus sign here, minus here, then what we're saying is that this point here is lower voltage than here, right? Same thing we said here. This is lower than this. So when the mesh is coming this way, it's going through, and it's actually going to a lower voltage. So you're gonna have a minus V2 there. Again, don't worry about it. It just is how it is. You get used to it. Okay, so that then now you end up here. You end up kind of going back, and then you finish the mesh loop. So this here is the KVL for mesh I1. So for example, mesh 1. Okay, let's do the one for mesh 2 or I2. So you go around here. Let's start from this point here. You're meeting V2 at its negative terminal, so that means you're having a voltage rise, right? So we're saying plus V2, and then you're meeting R3 or I3 at its negative terminal here again. So that means you're going to have again a voltage rise of I3. And then so now we're coming at R2 from the negative terminal again. That means you're going to have a voltage rise of I2. And then finally you're coming along here, back to here at the positive terminal of the 10 volt battery. And that means you have a voltage drop of V3. Cool. And then the thing to just remember with all of these KVLs and KCLs is that all of them are equal to 0. Okay, so that's it. Now we've done the KVL for each mesh. Now we're going to do the formula for the branch currents for each, resistor R1, R2, and R3. Cool. So what we can say, we're going to find out what I1 is, what I2 is, and what I3 is, and this is in terms of the meshes. The reason why we're going to do that is because once we find out what these are, we're then going to substitute them into here, right? Okay, so I1 over here, if you say, does this mesh I2, does it have any effect on I1? Does it go through R1? The answer is no, it doesn't. So what we can say is that the I1 mesh is affecting only, R1 is only affected by the mesh I1. So I1 is equal to lowercase I1, the mesh, right? Now, does it hit it, or does it approach it from its positive or its negative? The answer is it approaches it from its positive terminal, right? So we can say that the current going through that is positive I1, right? Now, if we look at I2 over here, this mesh here is going round this way, and I1, this mesh here, doesn't affect R2. So we've got the mesh coming around here, and it's going through the resistor here, and it's going through it at its minus terminal, right? So it's a negative current. That means that I2 is actually negative I2, right? Now, finally, I3, in terms of the meshes, this I1, if we should have done it in a different color, if we say that this is I1, it goes through this resistor like that, from the positive to negative. So we can say that it's plus I1. And then this mesh here, I2, goes through the resistor R3 from its negative terminal to positive terminal, or from negative to positive, even though I keep saying terminal, but obviously resistors don't have terminals, but I'm saying from its negative end. Then we're going to have minus, we have a negative current, so we're having minus I2. We've got plus I1 minus I2. And then we can just put that in brackets basically. So now we've got I1 in terms of the current through resistor R1 in terms of meshes is I1. The current through resistor R2 is in terms of currents minus I2, and the current in resistor R3 is plus is the mesh I1 minus the mesh I2. Okay, so let's substitute now these back into here, into these KVLs, right? Okay, so when we're substituting them back in, the one thing we need to remember is that here we're talking about voltages V1, I1, I3, V2. These are voltages, right? So even though we're saying, you know, the current I1, when we're going to put them back in now, so if, for example, when we write I1 is equal to V1 minus, and then we're going to substitute in this I1 here into I1, right? The capital I1. This capital I1 is actually V equals IR, right? So we have I1 times the resistor value of R1, right? So V equals IR. So I1 times R1, and then we're going to do minus. Usually we wouldn't write this out, but I'm just showing you just in case you've forgotten. So minus I3, which we've said already, is I1 minus I2, and then that is times by the resistor of R3, right? And then minus V2. Okay, so the reason why we're doing that, if you think about it in terms of let's do R1. Okay, so V is equal to IR. So then if we're saying that the current I is equal to I1, right? Because we're saying it's here is equal to I1. So the voltage is equal to I1 times the resistor value R1, which is 20 ohms, right? So we could say it's 20 I1. This voltage here is equal to 20 I1. So this is what we're going to be writing down here. So here we're going to have V1 minus 20 I1. And then we're going to say minus, and then we're going to put the value of R3, which is 20, and then it's going to be 20 times I1 minus I2, and then that minus V2 as well. Okay, then we can substitute in the values for the voltages. So remember, we have these values. We have V1. V1, the voltage already is 6. So we can say 6 minus 20 I1 minus 20 times I1 minus I2. And then minus V2. What's the value of V2? 4 volts. 4. And then we can simplify that. So 6 minus 4 is 2. So we can say minus 20 I1 minus 20 I1 minus I2 minus 2. And then all of that is equal to 0. And this is mesh 1. Cool. So let's do that. If you didn't get that, don't worry. Let's just do that again for mesh 2. Okay, so we've got V2, which we know is 4 volts. So I don't need to put the volts. Because these are the KVLs, right? So we know it's in voltage anyways. Then I3, which is equal to I1 over here minus I2. So I1 minus I2. But then we also know that it's obviously the resistor value of I3, which is 20. And then it's plus I2, which we know is minus I2. But then we need to put the resistor value as well. So the resistor value of I2 is here 40 ohms. So it's minus 40 ohms. Minus 40 I2. And then minus V3, which I believe is 10 ohms. Yes. Sorry, 10 volts. So cool. So we've got 4 minus 10, which is equal to minus 6. So we can say 20 I1 minus I2. I just realized I made a mistake on the last mesh, but I'll correct that now. 20 times I1 minus I2 plus, so it's not actually plus, it's minus here. Because there you can see it's plus minus 40 I2. So minus 40 I2, and then 4 minus 10 is minus 6. And all of that is equal to 0. And then what I forgot to do here is I forgot to expand out these brackets. So I'm going to expand out these brackets and then I'll go back and expand that one. So we've got 20 I1 minus 20 I2 minus 40 I2 minus 6. All of that is equal to 0. And we can simplify that a bit more. 20 I1 minus 60 I2 minus 6 is equal to 0. And there we have the mesh 2. Cool. And then let's just simplify, just multiply out these brackets. So minus 20 I1 and then minus 20 I1 again. And then minus 20 times minus I2, which is plus 20, right? So plus 20 I2 minus 2 is equal to 0. Simplify this a bit more. So we've got minus 40 I1 plus 20 I2 minus 2 is equal to 0. And there you have it. That's the actual simplified version of the mesh KVL. Cool. Let's just copy and paste this, bring this down a bit. Alright. So now we've got our two KVLs. So we're substituting into KVLs, and now we need to just do our simultaneous equations for both of them. Okay, so we know that they're both equal to 0. So let's times M2 by 2, and then that will give us 40 I1, and we'll match this up with this as well. So times this by 2, so we get 40 I1 minus 120 I2 minus 12 is equal to 0. We can call that A. Right, so now all we need to do is just do M1 plus A. So basically adding this equation here with this one here, and then we can work out what the values of I1 and I2 are. Alright, so I've just noticed the dumbest mistake. So here you can see it says 6 minus 4. 6 minus 4 is 2 plus 2, not minus 2. So this needs to be plus 2, plus 2, and plus 2. Yeah, I always do this. Why? I've just gotten in the habit now of just double checking. So always just be in the habit of just double checking, because this happens to me a lot, trust me. Okay, so now let's add m1 and m2, let's add m1 and a together. So we've got minus 40i plus 40i is equal to 0, and then we've got 20i2 plus minus, also 20i2 minus 120i2 is minus 100i2, and then you've got 2 plus minus 12, which is minus 10, which is equal to 0. And then so you get minus 100 I2 is equal to 10 when you add obviously 10 onto both sides. That leaves you with minus I2 is equal to so it's 10 divided by 100, which is equal to 0.1. That means minus I2 is equal to 0.1 amps. And then now we can replace, or so we can put, sorry, wait, what am I doing? Obviously, so I'm not going to leave it as minus I2, make it I2 is equal to minus 0.1 amps, right? Because you're just inverting it. All right. I was about to leave it as minus I2. So I was about to put minus I2. So put I2 into M1, right? So we're going to put this I2, and we're going to put it into this equation here. So we've got minus 40 I1 plus 20 times minus 0.1 plus 2 is equal to 0. So minus 40 I1, and then so 20 times 0.1 is going to be minus 2, right? And then plus 2 is equal to 0. So you've got minus 40, this is a weird one, minus 40 I1 plus 0 is equal to 0. So you've got minus 40 I1 is equal to 0, which means that if you divide both sides by 40, you get minus I1 is equal to 0. And then obviously invert it, so I1 is equal to 0. That's an interesting one. Okay, so what we're saying here now is that the current through this loop here is 0. Interesting enough. Okay, so we've got those two mesh currents. All right, so we've done our simultaneous equations. The last thing we need to do now is basically substitute in the values that we just got for I1 and I2, which is the two meshes, and substitute them into the original equations that we had for each resistor, I1, I2, and I3. So going back to here, what we're going to do now is we're basically going to put I1 into here, and then that gives us the value of capital I1. Put minus I2 into here, and that gives us the value of capital I2. And then put I1 minus I2 into here, and that'll give us the value of I3, which tells us then how much current is going through this resistor versus this resistor and this resistor here. And that's it, we're done. You can see it's quite complicated, but it isn't. You know, it's one of those ones where it's like, if you look at this circuit here anyways, it's complicated. You know, there's a lot going on here. So it just is what it is, but it's not too difficult to understand. All right, so let's wrap this up then. We'll just mark this off here like this. Let's copy and paste in our values, get rid of our highlights here. So what we can do is we can say I1 is equal to I1, and we've already said that the value of I1 is 0, so therefore I1 is equal to 0 amps. And then we can say I2 is equal to minus I2, which means that it's minus 0.1, which is plus 0.1. Minus times minus is plus. So minus 0.1 is 0.1 amps in I2. And then I3 is I1 minus I2. So you can get this one wrong easily. So we've got I1, which is 0, and then we're minusing minus 0.1. So again, it's just 0.1 amps, and that's it. There you have it. Now we have the mesh currents for each mesh. I1 is 0, I2 is equal to minus 0.1, and then we've got the currents through all of the components as well. It's not pretty. let's just say that it's not pretty. All of that is you know, there's a fair amount of work to do, but the thing to know is that as long as you understand the method, then when you're making mistakes and you're getting when you mismultiply something here or something like that, then you can always check you can always go back and correct it. The most important thing is that you understand the method, that you keep in mind these 6 points. As long as you're doing these, both these for nodal and mesh, you'll be fine. And you know what? It's funny because the other circuit analysis methods are actually almost easier. They're almost less work as well. So yeah, maybe not superposition actually. That's probably quite a bit of work. Yeah, I'm very happy with that. Hopefully you enjoyed this video. If you did, leave a like, and yeah, we'll jump onto superposition in the next video. See you soon.